Let's look at functions in C++. In this video, I want to show how functions are used. These are user-defined functions. Where do you put the code for the function? Where do you put the prototype? And how do you call a function? So this is going to be a review for many of you, I suppose, but I think it's good that we go ahead and go through functions in C++ anyway. The program that I'm going to use is going to be one where we're going to input a date in month, day, and year form, and we're going to make sure that that input is correct. That is, we can't have more than 12 months in a year. 13 or 15 would be wrong. And for the day of the month, well, those can either be 28, 29, 30, or 31. So we need to make sure that we don't exceed that for any month. And also the year, and that's going to be an arbitrary, for us. So we can make the year anything we want. But to do an example that makes sense, we're just going to have the year be between 2000 and 2025. This program is going to have three functions. In order to determine how many days there are in a month, then we need to know if we have a leap year or not. So one of the functions is going to be called days. I'm sorry, that's not the right one. That's the number of days in a month. So we have a function to return the number of the days in a month. And we do have the leap year function, which I'm calling leap. And it returns 1 if it's a leap year, and it returns 0 if it is not a leap year. And then I've got a function called validate. And that's going to test to make sure that all three numbers are correct. The month is correct, the day of the month is correct, and the year is within the range that we specify. I already have the body of the main program here, and as you've probably come to realize by now, we will start with a portion of a program, and then we'll just fill in the missing parts to illustrate whatever the topic is. So let's look at what we have already. Inside the main program, I've got unsigned integers, for the month and for the day and for the year, and those are set to 0. And I've got a character here that I'm going to describe as to how I'm going to use it. So character answer, and I just set it to the single character uppercase Y. And the reason I'm doing that is I want to write a loop in the main program that allows me to enter as many dates as I want to and then validate them without having to restart the program over and over again. So here's the beginning of this do-while loop. So the syntax is do with the curly brace here. So I guess we're reviewing the do-while loop at the same time here. Then if you scroll down, here's the bottom of the loop. So the bottom, we close with the curly brace, and then the while part goes here, and then you have your logical expression that goes there. So at the end of the program, I'm going to ask our user, which is most likely us, do you want to continue? That means that we want to test another date, and then you type in yes or no. Okay, so that is collected in that character variable answer that I declared up above. Then if the answer is an uppercase yes, or if the answer is if the answer is an uppercase Y, which is for yes, or if we forget to put down the shift key, let's also consider a lowercase y as being a legitimate response. So if we have either a lowercase or uppercase y, then the while will be true, and then we'll just go back up to the top of the loop again. So that's the do-while loop. Inside the loop, we are going to prompt the user to type in the date. Please enter the month, the day, and the year in that format. And then we just have the cin statement to read in those three numbers. We need to put code here in order to fill out the rest of this loop. And if it is a correct date, then we'll print out that the date has been validated, and then we'll hit the end of the loop and ask our user, do you want to do another date? So that's what we have so far. At the bottom of the program, there are a lot of comments. So this is where the functions go. And this is the correct place to put your functions. In my case, I've got some comments which give some description of the function. So this is the days and the month, and the inputs for the function, which will be those arguments that we pass in, we're going to have the month and we have to have the year in order to determine how many days there are in the month. Well, I suppose we don't really need that. Yeah, we do need the year because we need to know if it's a leap year or not. And this function is going to call our leap year function, and it's going to return the number of the days in the month. So here's a short description of what the function does, and it's a good idea to comment your functions, and this is a pretty short comment. It just gives the very essentials, and you can describe your functions even more if you want to. So I'm going to put the function for the days in the month here, and here is the location for the leap year function, and it only has one input. We have the year, and we find out if it's a leap year or not. If it is, it returns 1, otherwise 0. And then the last function is going to be the validate function. So the body of the functions go below your main program. And the validate function, as you can see, it's going to accept the month, the day of the month, and the year, and then it'll make sure that everything is correct, and it has to call the function days in the month in order to do that. This is a Boolean function. It returns true or false. Okay, so it returns true if everything is within range. It returns false otherwise. Now, let's begin this program by coding the bodies of these functions. We'll maybe do one at a time. Let's start with the leap year function. We're going to write a function here that will accept the input as the year, and it will determine if we have a leap year or not. We begin with the name of the function and the type of the function. So in C++, you need to specify what type your function is returning. You need to have a name for the function. In this case, it's called leap. And then in parentheses, you have the parameters that you're passing to the function. In this case, I'm expecting to have an unsigned integer passed in, and the variable within the function I'm using is going to be year. So when you are passing in a variable to a function, then I'm going to have to send in something that matches this unsigned integer. Then, afterwards, we have the body of the function, and that's just enclosed within the curly braces like any other block of code in C++. Now, the thing about the leap year, and you may want to go check this out, it's not just whether or not a year is evenly divisible by 4. There are special circumstances that go beyond that. And those are these. If a year is a centurial year, that is, it ends in a double zero, like 2000, 1900, 2100, then we have to consider if that year is evenly divided by 400. Now, if it is not evenly divided by 400, then that will not be a leap year. So the year 2000 is a leap year because it is evenly divisible by 400. Oh, okay, this popped up. I don't want that in there. So years that are evenly divided by 400 are leap years. But if you have a year such as 1900 or 1700 or 2100, those are not evenly divided by 400, so those are not leap years. So we need to write our if statements inside this program in order to take that into account. You might want to go look at leap years in Wikipedia if you want to know more of the history of the year, the calendar, and the leap year. Now, first of all, let's check for those special cases. Is this year going to be evenly divisible by 400? So here's the test we use for that. So if the year, and that's the modulus operator, so if year modulus 400 is equal to 0, well, that means that it is evenly divisible by 400. The remainder is 0. So it's a leap year, and we return 1. So that takes care of that special instance of those centurial years. Now, let's move on with the next part of our if statement. So we'll paste that part in here. And we have an else-if clause. So else if the year modulus 100, if that's not equal to 0, then that means it's a year that does not end in double zero. So this part of the else if is going to exclude any other year that ends in double zero. We've taken care of that situation up here. So if the year doesn't end in double zero, then we can see if it is evenly divided by 4. So that's this part. So if year modulus 4 is equal to 0, it's evenly divided by 4. And if both of those things are true, it's also a leap year. Now, let's close our if statement with the last part. So we'll paste the code in here. And it's just an else statement. So the first two parts of the if statement, those detect if we have a leap year, and if we do, we return 1. Otherwise, it is not a leap year, we return 0. In this function, we have 3 return statements. We have one here, we have one here, we have one there. And that's fine. You can have as many return statements as you want, but you must have at least one. Now notice we're returning a 0 or we are returning a 1, and all of those qualify as an unsigned integer. So the type of the function leap as an unsigned integer matches the return value that we give it here. So that's the body of the function leap. But we're not done yet. Whenever we have a function, then we also have to put a prototype, as it's called, up at the top of our program. The easy way to make a function prototype is to just copy the first line of the function. So I'm going to make a copy of that. Then I'm going to scroll up to the very top of the program, and I'm going to put the prototype here, right below my comment. It says define function prototypes here. What is a function prototype? A function prototype is just a copy of the first line of your function. So we'll paste that in. So this indicates to the compiler that we have a function. The function is defined below the main program, but the name of the function is leap. It's going to be an unsigned integer. It's expecting one argument of type year. This is necessary for the compiler in order to compile your program, because we're going to call the leap function in here. So if the leap function isn't defined, then the compiler is going to give us an error. But by using the prototype, we're telling the function that, hey, leap really is a legitimate name. It's just declared at the bottom of the program. The other thing you have to make sure you do here is to put a semicolon after the name and the arguments of the function. So that now is a function prototype. So those are 2 of the 3 parts of a function that you need. The last part is you actually have to reference the function. Okay, you have to call that function. So in here, we are going to call the function eventually, or call a function that in turn calls leap. So we will wait about putting the call in for right now. All right, so that is the first part of this. We have completed the function leap. There's the body, and up here is the prototype. Now, before we call the functions, let's go ahead and do the other 2. So I'm going to go down to my functions, and I'm going to do the function days in month. So we'll add the code here to do that. Like all functions, we need the first line. So this one is going to return an unsigned integer. The name of the function is days in month with those underscores. And this function is expecting 2 inputs. It wants to know what month, and that's going to be an unsigned integer, so it should be a number between 1 and 12. And it's also going to need the year, because in order to determine the number of the days in a month, we need to know if it's a leap year or not. And we're going to use our leap year function in here to determine just how many days there are in a month. So now we have the curly braces, as always. So we have the body of the function goes here. Now these arguments here, I'm not sure I mentioned it in the leap function, but those are called formal parameters. So these formal parameters, they have to be matched up with actual parameters when we call the function, and I'll talk about that again when we start to call the functions. Okay, now we have to put the code in here for the body of this function, and its purpose is to determine how many days there are in a given month. So we need an if statement, so let's paste the beginning of that if statement here. I'm going to have a local variable which I'm just calling days. So we need to calculate how many days there are in a month, so I need a variable in order to hold that value. So I'm going to declare it as an unsigned integer. I'll set it equal to 0. Okay, now February is our unusual month. So if month is equal to 2, then that will be February. And let's come back to that. Let's do the other months first. So we'll come back and we'll deal with February after we do the other 11 months. Now let's move on and get the code for some of the other months. I'll paste the code here, and let's examine what I've done. Now, if you look at the calendar, then you realize that there are 4 months that have 30 days, and we have February, and then all the rest of them have 31. So if we have the month for, April, May, and 9 is September, 11 is November. So if month is equal to 4, here's the or, right? So if month is 4, or month is 6, or month is 9, or month is 11. So if any of those are true, then the number of days in that month is 30. So that's pretty easy to do. And up here, we had the month is equal to 2. Now that makes the last part of this if statement really simple, because if it isn't February and if it isn't any of those days, every other month has 31 days. So we just set days to 31 in that case. So we put the code here for that. And if it isn't Feb, if it isn't any of those, then we have 31 days in all the remaining months. So that was pretty easy to do. Here's the end of our function. Let's take out some space. Once we're finished with that if statement, all we need to do is return days. Well, we've done everything except February. So how do we handle February? Okay, it could be 28, could be 29. So the way that we could do this, we could set days equal to 28, and then we can call the leap function. Remember, the leap function returns 1 if it's a leap year and returns 0 otherwise. So to get the right number of days for February, we add on a call to our leap function. And in order to call the leap function, we need to pass in the actual parameter, which is year. So that takes care of February. So that's kind of a neat little way to do that. So if the month is 2, it's 28, plus we'll call the leap year, and it will add 1 or it will add 0. So now we have a complete function that will give us the number of days in the month. Before we call this function, we need to be absolutely sure that we validated the month first. Because if we call this function with a month of 15 or -1, then it's not going to give us what we want. It would give us an error. So before we call this function, we're going to make sure we validate the month, and we'll see that coming up. Now, as in the other function, with leap, we need to make the function prototype. Easy way for the prototype, or easy way to make it, just copy the first line, go to the top of the program, paste it in. So we'll put it here, and add a semicolon. So there, you've got your function prototype. And the textbooks, they will show you that you don't actually have to include the name of the variable here. Okay, that's not absolutely necessary, but it's okay if you leave it in there. And it's easy just to copy and paste if you do leave it in there. We still aren't calling the function. We called the function leap up here when we did the number of days in the month. So we call the function here. So here's an example of how you call the function. So when we call the function leap, we need to send in the actual year, and then that year is going to go into the formal parameter year inside the function, and then it uses that year in order to determine if it's a 1 or a 0. Now, let's do the validate function. So this is the third of our 3 functions, and we'll paste in the code for that. And this is a type Boolean, okay, BOOL. That means that we can return true or we can return false. Nothing else will work. The name of the function is validate, and since we're using a date, I just tried to be clever and make that an uppercase date. And it needs to have 3 parameters. So I have these 3 formal parameters, month and day and year. Now, all 3 of these are going to be unsigned integers and unsigned integers. One thing I think I'll do here, and because I'm using day and days quite a bit, I want to change that to day of month. Okay, so let's use DOM here. All right, so day of month. So that will maybe make it a little bit more clear and not get it confused with the other days that I'm using in the examples. So that's the main line, the first line of our function. Now, what do we need to do with this function? Well, we need to validate the month first. We don't want to call anything until we know that the month is correct. Then we will see if the day of the month, we'll see if that's correct. And then finally, we'll check to see if the year is correct. So if all those are correct, then we have validated the date and we'll return true. So let's get the code to do that. So here's the code. So we say validate the month first. So the month can only be a number 1 through 12. So if the month is less than 1, or if the month is greater than 12, that's an error. So we do return false in that case. If you want to, you can print out the message that the month is out of range. So it just is up to you whether or not you want to see that information on the screen or not. It's probably a good idea to do that while we're developing and debugging the program. But later on, you probably are not going to want to see that, so you can remove it or just make it a comment. So that takes care of the month. If the month is 1 through 12, then this is going to be true, and we're going to, well, that's going to be false, and we'll exit the loop. So this is kind of testing the negative condition. Okay? If the month is less than 1, it's not a month. That's not right. Or if the month is greater than 12, outside the range. So if either of those are true, we return false. Okay? The next thing we need to do is we need to find out how many days there are in a month, and we will validate our day of the month that we're passing in. So let's get the code to do that. The first thing I need to do is I need to declare a variable for the days, because when I call the function days in the month, it will return the number of days, so I need to collect that. So let's set a variable days, which is an unsigned integer. And we'll just make that days, and let's just set that equal to 0 to begin with. All right, so now that I've declared this variable, I need to find out how many days there are in a month, and let's go ahead and paste the code in here to see what we need to do. All right, so to validate the day of the month, then I first of all need to know how many days are there in that month. So I'll call the function days in month. I'll send it the month, and I'll send it the year. So this will return how many days that month has. Alrighty, well, that's okay, but now what do we do? And I need to change this here. And I'm passing in the day of month. I changed that, so my apologies there. So let's fix this. There, all right. So if we, for example, pass in 11, okay, that would be November, then we would know November has 30 days. If we pass in 2 for February, then it could be 28, it could be 29. Regardless, the function days of month will tell us how many total days there are. Then, if the date, this day of month, if we're sending in a number that's less than 1, then that's not a correct day of the month. Negative numbers or 0 are not good days for the month. Or if the day of the month that we're passing in is greater than the days returned by this function, then that's also incorrect. So if I send in February the 30th, then the day of the month would be 30 for February, and that would be greater than either 28 or 29, so that would be an invalid day of the month for February. So we need both of these things. We need to find out, hey, how many days does this month have? And then we'll take the date that we're testing, and we'll see if it's a legitimate value within 1 up to the number of days in the month. If it is not, then it's false. Okay, so we will return false if the day of the month is less than 1 or if it's greater than the days in the month that we're investigating. And again, if you want to print out why this is bad, then you can just print out that statement. Otherwise, you can take it out or make it into a comment. So now we've done 2 of the 3. Okay, we've validated the month. We've validated we have validated the day of the month, part of the date. The last thing we do is validate the year. Okay, now the year is arbitrary, as I mentioned. It depends on your application. If you're doing a credit card check, then the range is probably the current year and maybe 5 years beyond. If you're checking someone's birth date, then you might want a range of maybe 100 years in here. And if you're doing some historical program, you might want it to be even larger than that. So it's an arbitrary thing. So let's now validate the year, and I'm going to choose an arbitrary range between 2000 and 2025. So we'll paste in the code to do that. And let's fix this bracket. I don't like for my curly braces to be over there. Okay, so now we'll validate the year. So arbitrarily, if it's less than 2000, it's not a good year. And if it's greater than 2025, it's also out of range. So we'll consider that to be an invalid year, and we'll return false. And again, if you want to print out the reason, you can. So these three if statements are going to validate the date that we pass in. Okay, we got the month, we've got the day of the month, and we got the year. Now, if everything is good, we want to return true. All of these cases return false. Okay, the date's not good. So if we pass all those tests, all we need to do down here is we just return true. So we drop that in, and that completes our function. Notice when you are returning something from a Boolean function, you literally return the words false or return the word true. So in C++, true and false are Boolean types, and that's the only thing that a Boolean type can be. We've completed now all of our functions. We need to make the prototype for validate, so let's make a copy of the first line and scroll up, paste it at the top, and add a semicolon. All that's left to do now is to call these functions in the correct order in order to validate our input. So let's go back to our loop, and then we need to add code here to investigate any date that we want to type in. We've typed it in here, now we need to validate it. Let's look at the while loop that we're going to use for that. So when we call the function validate, it returns true or false. If it returns true, then not true is false. We'll stay in the loop, and we want to tell our user that, hey, the date you entered is not correct. You need to enter another date. So validate returns true or false. If it returns true, then not true is false. We exit the loop, and we print out that the date has been validated. Okay, so note the logic there. Okay, if it returns false, then not false is true. We stay in the loop. If it returns true, we have the not true. That's false. We exit the loop. So we're going to take the month, the day, and the year, and we're going to pass them in to the validate function. The validate function, it has to call the days in the month function. The days in the month function has to call leap. So we have kind of a cascade of calls going on there. But in the end, we're going to get back either true or false from this. Now, if we get back a date that is not correct, then we want to tell our user, and we want to let them input another date. So let's add the code in for that. So we'll put that code here inside this loop. So if they put in a date that wasn't correct, then we'll tell them they need to try again. Okay, so we'll say, please enter the month, day, and year, and then we'll do the CN statement and give them another chance in order to put in a correct date. So it's not going to be possible for this program to continue until a correct date has been entered. When a correct date's entered, then we'll print out that it's validated, and then we'll ask them, our users or ourselves, if we want to do another one. So that completes the program. So here we have the call to the function, and inside those functions we got calls to functions, and we have the prototypes at the top. We have the bodies of the code with the bodies of the function. The code is down here. That's the correct way to format your functions. Now we are going to run the program. So at the beginning we have our do while loop up here. So we'll see the prompt to enter the month, the day, and the year. So let's bring over the output, and you'll see that we have that prompt up on the screen. So let's scroll up a little bit. And we now need to enter the month, the day, and the year. All right, so let's do that. So let's type in a good month first. Let's do 4 April 12, 2010. That should be a good year. And we do get the date has been validated. Okay, do you want to continue? Well, that's coming from the bottom of the while loop. So here's the bottom of our do while. And before we get there, we prompt, do you want to continue? We'll type in yes or no. All right, so that's what this do while loop is allowing us. We can test a lot of dates without having to restart the program. Well, let's try to do another one then. Let's do yes to continue. Now let's type in something that we know is not correct. Let's type in February 30th of 2000. Okay, so let's enter that, and we get the value for the day is out of range. Okay, so that means that we're still inside the loop. Okay, we're still inside this, so it's going to prompt us to type in the date once again. And that's what you see here with this prompt. So we're still inside the loop. The only way we can get out is to type in a date that's correct. But let's try a few more that are not correct. So let's try July the 54th of 2009. Okay, so that says the day is out of range. Yeah, okay, 54 is not a good day. Let's try another one. Let's try December the 23rd, and let's make the year out of range, 2030. So we arbitrarily said you can't go more than 2025. So it says, hey, the year's out of range this time. Okay, now let's keep going because these are invalid dates. We haven't gotten out of our loop yet. So let's put one in that is correct. So let's try, May the 15th of 2004. Okay, so now that's a good date. Do we want to continue? Yeah. So let's try a couple of others. Let's try one of the regular days. We've done. Let's do a leap year. Okay, let's try one with a leap year. Okay, let's do February the 29th, which is a good day for the year 2000. That's a leap year. Okay, so we type that in, and it's validated. So our leap year function is working. We validated a year that is a leap year. Yes, we'll continue. Let's try an ordinary leap year. All right, so let's do 229 of the year 2008. Okay, that was a leap year, and it's validated. So you get the idea now. We have a little program that will let us make sure that the data that are entered for a date is correct. And once that's done, then you might want to proceed and do something with that information. Okay, well, let's do one more. Let's just do a month that's invalid. We didn't do one of those yet. So let's try the month number 14, the day number 12, the year 2001. And we find out that the month is out of range. So this now has given us a test case for all three possibilities. All right, so let's get out of here. Let's do a July the 12th of 2020. And that's validated. And we've done enough test cases, so I'll type in and we'll exit the loop, and our program will be over. So this then is an example that shows you the syntax for functions. These are your user-defined functions. So remember the structure for this. Remember the three things you need for functions. You need the function body, you need the prototype, you need the call to the function. Many of you know that if you place the body of the function up here where the prototypes are, then it works just fine as well. But that is not a good programming technique. You never want to put the body of your functions prior to the main program. That is not considered good programming style, even though it does work. Well, now I think we've done a nice review of at least these functions, so let's terminate the video at this point.